All right. Hi, everybody. So today we're going to be talking about 4.3, which is solving inequalities using multiplication or division. So at this time, make sure you have your math composition notebook out, please. You should be writing down everything that's on my screen. Feel free to pause as we go through so you can get everything down in your math composition notebook. So to start, let's write down the learning target, which is I will be able to solve inequalities using multiplication or division. So again, in 4.2, we looked at solving inequalities using addition and subtraction. And you probably found that it was kind of review from chapter 3, solving equations. So 4.3 is going to be exactly like that, except we're going to just be solving inequalities using multiplication and division, which you already had practiced doing in chapter 3. So let's just get right to it. So we're going to kind of do the same thing that we did in both 4.2 and chapter 3. So we're going to look at this. X over 5. I'm actually going to rewrite this so we have more space. So we have x over 5 is less than or equal to negative 3. Okay, so you can draw a line down the center. Then first thing you want to do is obviously we want to pay attention to the side with the variable on it, which is the left side. And then you want to decide, okay, how are the x and the 5 being attached? And so how are they being attached? Multiplication or division? Well, I hope you said division. So remember, in order to undo division, well, let's remind ourselves, so write this note, division and multiplication are inverse functions or inverse operations. Okay, so just remind yourselves, division and multiplication undo each other. So if I want to undo this divided by 5, I'm going to need to multiply both sides by 5. And remember, we show that as 5 over 1, okay? And multiply by 5. So these cross cancel. We're left with x. Don't forget our sign is less than or equal to negative 3 times 5 is negative 15. Okay, so we have now solved for x. So now remember what we have to do with these is our last part. It says graph the solution. So I'm going to graph it. And here's a little note. You don't have to always go by ones. You can count by different things when you make a number line. You just have to make sure it's consistent. So I'm going to go by 5s. 5, 10, 15, 20. You just have to make sure it's consistent. And then I'm going to do negative 5, negative 10, negative 15, negative 20. Okay? So remember, what we have to do first is we have to plot that point that we solved for. So it's going to be negative 15. So I'm going to write a circle around negative 15. Then we have to decide, are we going to fill in the circle or are we going to leave it open? So I want you to decide right now. Are we going to fill in the circle? So I need you to take a peek at this inequality, less than or equal to. Are we going to fill in this circle or are we going to leave it open? So I hope you all said we are going to fill it in. The reason we fill it in is because negative 15 is a solution, okay? So remember, it can be equal to negative 15 or it can be less. So it is a solution. So now the next thing we need to do is we need to test those points. So we are going to test a point on the left side. So let's write if x equals, on the left side would be, let's do negative 20. Then plug in negative 20 to the inequality. Negative 20 is less than or equal to negative 15. Is this true or false? Negative 20 is less than or equal to negative 15. I would say that's true. It's to the left side. It's less than. Okay, let's just check one on the right to be sure. So if x equals, let's say, 5, then 5 is less than or equal to negative 15. Is 5 less than or equal to negative 15? No, that is not. So that means we need to shade to the side where the negative 20 is on, which is the left side, okay? Then remember, so that's our graph right there. And then remember, let's remember how we would read this. We would read this as x is less than or equal to negative 15, okay? So that's how we would read that. And then, so think x is negative 15. X has to be less than or equal to negative 15. So therefore, we shade to the left. All right, that's our first example. Make sure you get that down. And then let's scroll to number 2. So solving an inequality using division. So same thing. Draw a line down the inequality symbol. And then you want to pay attention to the side with the variable on it. And how is the 6 and the x being attached? So remember, if you have a number and a variable and they're being attached, what operation is attaching them together? Well, I hope you're thinking multiplication. So in order to undo multiplication, you need to divide. So we're going to divide both sides by 6. 6 divided by 6 will leave me with just 1x. Then write your inequality symbol. Then we have negative 18 divided by 6. Well, that's going to give me a negative 3. So I have x is greater than negative 3. And again, I'm just going to write it out because I want us to get used to this language. X is greater than, because the big alligator mouth is facing the x is greater than negative 3. Okay, so that's how you would use that using words. So I just want us to get in the habit of doing that. Now we need to graph it, remember? So we are going to make a number line. This time I'll just go by 1 since negative 3 isn't that far away. So I'm going to go negative 1, negative 2, negative 3, negative 4, negative 5. Okay, we need to plot our point at negative 3. So I'm going to write that circle there. Then we need to decide, is it an open or closed circle? Well, you need to take a peek at the inequality sign. What tells us whether it's open or closed? Hopefully you said the line underneath. And is there a line underneath of this inequality symbol? It also doesn't say is greater than or equal to. So therefore, negative 3, it's an open circle since negative 3 is not a solution. Okay, so negative 3 is not a solution. So let's figure out where we're going to shade. Let's test a point on both the left and the right. So if x equals, let's do negative 5 because that's on the left. Then negative 5 is greater than negative 3. Is negative 5 greater than negative 3? No, because that's a bigger negative number. So that's not correct. So now let's try a number to the right. Okay, so if x equals 0, then 0 is greater than negative 3. Is 0 greater than negative 3? Yeah, it is, because negative numbers are smaller than 0. So that is a yes, which means we need to shade in that direction where the 0 is, which is to the right. So we're going to draw our shading like that, and that is our graph. Okay, so that is example 2. Make sure you have that down. So the important thing that you have here is that you have boxed in your inequality. So x is greater than negative 3. And then you also have your graph with the proper shading. That is what you need to have on all of your assignments. Okay, let's scroll down because we're going to get to a very important rule. So you don't have to write down this exact language because I'm going to write it in a simpler way. But essentially what this is saying is when you multiply or divide each side of an inequality by a negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. So we're going to write this in simpler terms. So you can just write what I'm writing over here. So, and that is, if you multiply or divide by a negative number, the direction of the inequality symbol flips. Okay? So that is our rule. If you multiply or divide by a negative number, the direction of the inequality symbol flips. Okay? The line still stays the same. Okay? If there's that line underneath, you still keep it the same. It's just the direction. So let's say you were to have this. If you multiplied or divided by a negative, it would flip to that. Okay? If you had this, it would then change to this. Okay? So that's the flipping that you would do. So let's look at an example of this, and then we'll try it out on our big ideas assignment. So example 3, solving inequality using multiplication. So I'm going to rewrite this. So negative 3 over 2n is less than or equal to 6. Draw a line down the middle. Okay, so this fraction, well, we want to pay attention to the side with the variable on it, which is this side. And then I see that a fraction is attached to the variable. So how is that being attached? Well, hopefully you're thinking multiplication, which means we need to divide. So we're going to divide both sides by that number in front, including the negative side. So we're going to divide both sides by negative 3 over 2. Wait, what did we just do? We just divided by a negative, which means since we divided by a negative, these are going to cancel, okay? And I'm going to write n. Now wait, do I just write the sign just like it is? So hopefully you're thinking you have to flip it because that's our rule. If you divide or multiply by a negative, the inequality symbol flips, okay? So the inequality symbol is going to flip. I'm going to write that over here. Inequality symbol flips since we divided by a negative. Okay, so I just want to make sure we get that. Anytime you multiply or divide by a negative. And what that means is it has to be the number that you're actually multiplying or dividing. If the number over here is negative, it doesn't matter, okay? But it's just if you are multiplying or dividing by a negative, you have to flip it. So now let's do 6 divided by negative 3 over 2. Let's remember our rule, keep, change, flip. I'm going to write 6 as a fraction, which is 6 over 1. Change the division sign to multiplication. Flip this fraction right here, negative 2 over 3. Then we can cross cancel. So 6 and 3, what could go into both? Well, 3 could go into both. 6 divided by 3 is 2. 3 divided by 3 is 1. Then multiplying fractions, numerator times numerator and denominator times denominator. That's going to give me negative 4 over 1, which is just equal to negative 4. So n is greater than or equal to negative 4. And that is my answer. I flipped it and everything. Okay, so now we need to graph it because that's always our last piece. So I'm going to write 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4, negative 5. Plot your point at negative 4. Open or close circle. Do we leave it open or closed? Look at the inequality. Is there a line underneath it? Yeah, which means we have to fill it in because negative 4 is a solution to it. Okay, now we need to figure out the shading. So let's test a point on each side. So if x equals negative 5, which is to the left, then negative 5 is greater than or equal to negative 4. Is negative 5 greater than negative 4? It's a bigger number, but it's negative, which means it's smaller. So that is wrong. It is not bigger. So now let's do a number to the right. If x equals negative 1, then negative 1 is greater than or equal to negative 4. Negative 1 is to the right, which does mean that negative 1 is greater than negative 4. So that means we are going to shade to the right on this graph. And that is our final answer. Okay, so we have the n is greater than or equal to negative 4 boxed in. And then we also have our graph, which shows that. Okay, so that is your final answer. Remember our important rule. If you multiply or divide by a negative, the inequality symbol flips. Everything else is pretty much just the same from chapter 3 and 4.2. All right, thank you for watching. And we will get started on the big ideas assignment soon.